In this video, I want to explain the process of subsurface storm flow, which is sometimes also called groundwater ridging, ground or water table ridging, I should say. So here's the situation. We've got a stream coming out at us, a cross section of the earth, and the blue line is the water table. And subsurface storm flow has to do with the movement of water from the groundwater zone into a stream rapidly, right? So normally we know that there's base flow, right? Coming up like this, and base flow is generally thought to be slow, and it's something that feeds the stream continuously, but it's not a major component of runoff, right? Runoff are those processes that move water rapidly from the land into the stream. So subsurface storm flow occurs because as water penetrates into the ground, it is going to affect the position of the water table. And the idea is there's a couple ideas here that come into play. One is that the moisture content of the soil zone is highest near the water table. So let this gray area represent the part of the water table that has a high moisture content. It's not saturated, right, because it's not below the water table, and it's not the capillary fringe, but it's got a high moisture content, so it won't take a lot of extra water to fully saturate it. So what happens then is as precipitation falls and we get infiltration into the ground, let me try that again. We get infiltration like this into the ground. This water is going to reach the groundwater system a lot faster near the stream than it is farther away for two reasons. One is it doesn't have as far to move, right? Because the surface is closer to the water table, closer to the stream. And the other reason is that as soon as it penetrates into the soil, it reaches that zone that's nearly saturated, and therefore you don't need to add a lot of water to fully saturate it and raise the water table. So the result of this is that what happens immediately following a stream is that the water table takes on a position that looks like this. So it's artificially high near the stream as that infiltrated water makes it to the groundwater system and lifts the water table. Now at this point, what I need to do is sort of review something about Darcy's law, or maybe talk about something about Darcy's law we haven't actually studied yet. Here is Darcy's law. It's one form of Darcy's law where I'm expressing the velocity of groundwater flow as a function of the hydraulic conductivity K, the porosity N, and this is the part I want to focus on, the hydraulic gradient, the change in the head divided by the distance. Now, in terms of the change in the head, we will show that the driving force for flow into a stream due to base flow is the difference between the level, the elevation, measured, remember, from an arbitrary datum. We could just use the bottom of the slide. So if you want, this is the head here, right? The head, we'll call this head at the stream. This is the lower value of the head, and the higher value of the head is essentially the water table. So previous to the storm, then this would have been a point on the water table here, right? And this would have been, let's call this head in the water table here, okay? And the difference that drives the flow is this difference in head here. That difference in head divided by the distance. But you can see what happens because of the raising of the water table, or the ridging of the water table near the stream, is what we've created is a much steeper slope to the water table. So essentially, this thing here, dH dx, this is approximately in an unsaturated aquifer near a stream. This is approximately the slope of the water table. And so the steeper is that slope of the water table, the more rapidly water will flow. And that's basically what subsurface storm flow is. As we raise the water table in the vicinity of the stream, we increase the rate of flow of groundwater flow into the stream. This is going at a much faster rate because this gradient, this slope, is much higher than it was previous to the storm. And so we're sort of getting sort of enhanced base flow as right near the stream as a result of lifting the water table in the immediate proximity of the stream. And that is the cause of subsurface storm flow, or also called water table ridging.